Yeah, welcome to Brainbox. See, these are the examples what I have taken to explain about the law of conservation of mass and even the law of constant proportions also. So first of all, we'll see about law of conservation of mass. So what law of conservation of mass says is that mass is conserved during a chemical reaction. So to explain this, I have taken one chemical reaction. See, this is your chemical reaction that we have the base reacting with an acid. So we call this as a neutralization reaction. So for this neutralization reaction, what we are getting is salt with water. And to exemplify this, I have just calculated their molar masses. You see here, sodium, there is one atom of sodium, one atom of oxygen and one atom of hydrogen here. And I have just taken their atomic masses separately. So 23 is the atomic mass of sodium, oxygen has 16 and hydrogen has 1. So the total sum is making 40 units, which is the molar mass of sodium hydroxide. And similarly HCl I have taken. So HCl is what? 1 unit of hydrogen and 35.5 units of chlorine, because the chlorine atomic mass is exactly 35.5, right? And the total is making now 36.5. And now see the sum, which means the total mass of reactants is now making 76.5 units. Now let's come back to the products. Now for products, the mass here is, we will take sodium and chlorine. Now see, sodium atomic mass we know well, that is 23, and chlorine atomic mass it's 35.5, and now see you got a 58.5 units of NaCl. And similarly water, see in water you have 2 atoms of hydrogen and 1 atom of oxygen. Then each atom of hydrogen will make 1 unit whose atomic mass is 1, and oxygen is making 16 units. So overall the atomic mass of water is making 18U, right? And then see this, the total mass which is on the product side is again 76.5 units. And you can see clearly here the total mass of reactants is equal to the total mass of products. Then what does it prove? That mass is remaining same during a chemical reaction. So from this, can we say that mass is conserved? It means that neither created nor destroyed. Okay, mass is neither created nor destroyed. It just is conserved during a chemical reaction. So this way we can understand about law of conservation of mass. And now let's come back to the law of constant proportions. So law of constant proportions says very clearly that the composition of a given chemical substance always remains same during any chemical reaction. Means the composition, for example, we will take water. Okay, so for water, its molar mass is completely 18U. So that we have calculated here, you can see here. So 18U is the molar mass of water, and that molar mass of water remains same whatever may be the source you got the sample from. In the sense, you get the sample of water from sea or river water, or you obtain it by the combination of H2 plus O2. But whatever it may be, your 18U remains same. Moreover, you see this. This is the way how we have calculated percentage by mass ratio of the elements present in water. So what are the elements present in water? They are hydrogen and oxygen. Now hydrogen, as 2 atoms of hydrogen is there, it makes 2 units, and there is 1 atom of oxygen, so it makes 16 units. So the ratio of hydrogen to that of oxygen in water is 2:16, which is making 1:8. So what is the percentage by mass ratio of hydrogen to that of oxygen in water? Means it is exactly 1:8. Now similarly, we can even take it for CO2. See, for CO2, you have 1 atom of carbon which is making 12 units and 2 atoms of oxygen. So you know each atom of oxygen is 16U. Then 2 atoms of oxygen in the sense 30. Okay, then what you will get the ratio? Means the ratio of carbon is to oxygen. Carbon is to oxygen is equal to, I'll divide the ratio by 3 with 3, means it is 4 3 is to 8. Right? The ratio of carbon to that of oxygen is 3 is to 8, and this remains the same wherever you get the sample from. Means the sample of a given substance can be obtained from different sources, but the percentage by mass remains same. Have a look at this.